let Phil Archer do his thing.
And if Ruben is late, you have to keep listening to me until he turns up. So good morning. I apologise to come to Flanders and speak in English. I'm sorry, I can do no other. The number of people of your age who are native English speakers who speak any other language at all is, well, you could fit them all in this room. So I apologise for that. So if you'll put up with me, and if I go too quickly because I am a native speaker, please tell me, and I will slow down. So this is an unusual talk for me. Usually I go to conferences about government data and open data this and open data that, sometimes linked data events and so on. So to come and spend time with people who actually know what they're talking about and actually spend their time writing code and doing stuff is something I need to do more of. Because my job actually is to, what this title of data activity lead means is, that it's my job to find out what standards we should be doing next, what we need to do, and that only works, as we'll talk about in the next few minutes, if the community is demanding it. So given that I know you're all less than half my age, I thought I'd start with just a very brief little bit of history. You're probably born in, you may have been born in 1989, I don't know. I was. I was a frightening age already in 1989. It's the year of the East European revolutions. A huge amount of things, a huge number of things happened in 1989. And in March the 12th, 1989, Tim Berners-Lee made his proposal called Information Management and Proposal, and he sent it to his boss, Mike Sandel at CERN, who immediately rejected it because it was a silly idea. And famously it said vague but exciting across the top and stuck it in his desk drawer, and that was that. And Tim went back a year later and said, look, I really think, Mike, you really should have a look at this. And the rest is history. So 25 years since Tim had the idea, 20 years since W3C was established to try and take the ideas forward. This diagram is one, have you seen this diagram before? Okay, this is on the front page.
It was on a paper napkin, the first diagram.
Probably, yes. And it ended up, this is a copy of the thing that was on that information management and proposal back in March 1989. And it includes a number of things that people very quickly overlooked and forgot. Linked data is here. Semantic web is here. The web of documents is here. You know, here is a person. Tim's on there somewhere. This document here describes this. It's linked to that. Here's the stuff about CERN. Here are individual people. It's all there, right from day one. It was always intended to be a way of linking together people and ideas and definitions, and yes, documents, and yes, applications, and yes, interactive goodness. So that's a very old picture of Tim with one of the very early browsers built on his Next computer, one of the forerunners. One of the computers that Steve Jobs made. Actually, when he stepped away from Apple for a time, he built a thing called the Next Cube, and then went back to Apple. And it was the Next Cube that Tim used to build the first server and the first browser. So where are we today? Well, we're waiting for a picture to download. That's where we are today. Okay. These are people I'm privileged to work with. There are some missing, but I want to run through not necessarily the individuals, but what they represent. Because it's an important part of what the web is and what we do today. So the guy you're looking for is here. That's what he looks like today, or what he looked like last November. Actually, he got married 2 weeks ago. No, I wasn't invited, don't worry. But other people are here who you might, if you won't necessarily know the people, but you will certainly know their work. Who's ever written an HTML form or an HTML table? This guy, Dave Rager, right? He's the first person who defined table, TR, TD, and all that sort of stuff, right? That's Dave. And forms and the input elements and all the rest of it. One of the very early, he was actually working on hypertext before Tim. So Dave is rather important. Ever written a CSS definition? Okay, that's Bert Boss, the guy who co-invented CSS with Hock and Lee from Opera, who then went off to form Opera. Some other really people who represent an important part of the web. Shadi Buzara, Judy Brewer, Michael Cooper. They are some of the people, and they're not, sorry, there's some people missing from here, but they're part of the team that work on accessibility. The web is for everyone. Tim famously tweeted at the opening of the Olympics a couple of years back, this is for everyone. The web is for everyone. No matter your color, creed, handicap, religion, language, whatever it may be, it is for everyone. And the Accessibility Initiative makes sure that no matter what your disability may be, you are able to access the web in a way that makes sense to you. The person not in the picture because he's taking it is Richard Ishida, who leads our international work. And he makes sure that you can write in any language, you can write in accented characters, you can write right to left, top to bottom, all the rest of it. So making sure that the web really is truly for everyone, irrespective of language, color, creed, or ability. Some other people who do really important stuff. This is Wendy Seltzer, you may never have heard of. Harry Halpin, you may have met, may have come across. Wendy and Harry are two of the people concerned with security and privacy. They make sure they constantly try to improve the security of the web, make sure that when you do stuff online, the NSA has a harder time getting at it than they did before. And we're trying to improve that all the time, of course. But Wendy is also working with Rigo Venning. And Wendy and Rigo are people who, they are, first and foremost, they're lawyers. Why do we employ a couple of lawyers? Well, one of the fundamental things about the web is that it's open and it's free. And there are all the standards that drive the web. Every standard that we create is royalty-free. You can build a multi-billion-dollar industry on it, and you never have to pay for it, which is not true of things like Bluetooth or Wi-Fi, whatever. If you implement a device that uses Bluetooth or Wi-Fi or whatever it may be, you have to pay someone for doing that. You don't have to pay someone to use the web. There are other people there. There's Don, who's mobile activity lead, so he makes sure that things work on small devices and so on. So there's a whole bunch of people there. This guy with one of the odd beards in the group, Renoir, they do developer relations. They're much more used to coming to this kind of event and working with developers and so on. This was actually taken in China last year. We had a meeting in Shenzhen, which is just over the border from Hong Kong. And my colleague Ivan Herman, who is based in France and in Amsterdam, and Doug Sheppers, they both have unusual beards. Ivan has this enormous, great big beard, and Doug has these little twirly bits that he cultivates. And the Chinese are absolutely fascinated by this. The Chinese locals, and we went out for the day. We had a day off, and we went to a temple, all plenty of time going around. And the Chinese kept wanting to take pictures of Ivan and Doug with their beard. And it was so wonderful to see this occasion when everyone's going, oh, we take picture, we take picture. There's a bloke called Tim over there that no one's heard of, no one knows anything about. Very good. Anyway, so the team is there because it makes sure that the web is secure. It's for everybody, and it does cool stuff. This guy, this is Philippe Legret, this is Ruben Verborgh, Mike Smith. Those are the people most directly concerned with HTML5. If that doesn't become a full standard by the end of the year, Philippe is going to start shooting people. But Ruben Verborgh, he's the main editor. He physically sits down and writes the stuff. So they're working hard on getting that through. Standards don't come about because we write them. In fact, we do very little writing. Robin is the exception because of the size of HTML and the importance of the project. Very, very few of our standards are written by the staff. They're written by the members. They're written by the community. And we don't have a top-down dictatorship, surprising as it may seem, because that doesn't work. There are standards bodies that work like that, but that's not the way the web works. It's not the way you work. It's not anything that's going to be of any use to you. When a group comes together, it's a group of, first and foremost, members, people who represent member companies, and almost every web company you've ever heard of is a member of ours. The almost being Amazon, which isn't and never will be. It's a separate argument. But you know, Apple, Microsoft, Google, they're all around the table, as well as many universities and small companies and so on. So we have a wide membership, which gives them voting rights, it gives them access to the working groups and so on. But even then, that large group of members is not necessarily the whole story. Yes, there are balding, overweight, middle-aged white blokes, like this guy. And yes, we have a role to play, and we make sure that things progress, and we have the conversations, and we try and drive standards forward. But we don't write the thing, and we don't create the demand. We simply try and recognize the demand. We talk to people and find out what needs to be done. The actual work itself is done by the members who sit around and actually get together on the phone every week and get together every so often. So yes, in any working group there are some people who are, if you like, on the stage doing the work, make sure that everyone is working together. But the most important people in any kind of working group actually is the audience. You can't see them there, but there's a whole bunch of people there watching this band whose name is Special Consensus. And the whole point about the open process is that everyone gets to have a say. And nobody is more important than anybody else, or less important than anybody else. So every working group has, usually, now almost, I think there are one or two exceptions, but all our working groups are in public. Every draft is on GitHub. Yes, we have formalized publication dates when we do certain things. Any document on a part of W3.org/TR will never change. Even you will be old and dead before a document changes in W3.org/TR space. Because that gives you that stability and that foundation on which to build. But before that, stuff is developed on GitHub and people collaborate and so on. But if you see something going on there that you want to comment on because you like something or you don't like something, whatever it may be, and you write to that working group, there's always a public mailing list that you can always write to, they must reply. And if they don't reply, the standard will not get through to the next stage. It's really important that everybody has a say, and this is why it takes a long time. It takes a long time to get a standard through the process because we have to listen to what everyone says, and we have to prove that we listened to what everyone said, and we have to prove that we replied to every message, and we have to prove that the working group considered every comment made. They may not agree with you, they may reject your comment, but they must give you a reason why they've done that. That's a very robust, detailed process, at the end of which you end up with something that is called a W3C recommendation, our word for standard, and it has that credibility, that gravitas, it has that stability, which is really, really important. Sometimes. There are other things that are developed in other ways that are used massively that have not been through that process. RSS is not a standard. GeoJSON is not a standard. Robots.txt is not a standard. GTFS is not a standard in the sense that this means. Now, if you do some work on geospatial and you don't use GeoJSON, you're an idiot. Of course you should use GeoJSON, or whatever it may be. Those things are very important and they're massively implemented. They are community standards and you should use them normally. But there are situations where actually, because it hasn't been through that process, there are actually problems with GeoJSON, minor problems. There are some issues around these things. And where it really matters is when it comes to building a multi-billion-dollar industry or running a government. So some governments have a policy of we will only endorse formally recognized standards. That can be a problem. So for instance, the UK government is never going to recommend using GeoJSON because it isn't a standard in the sense that we mean. It's not an open standard developed through an open process in a standards body like W3C or OGC or ISO, whatever it may be. There are loads of standards bodies. Loads of them. So consensus is really important. Getting that consensus within the working group and from the public. And when I say consensus, we very, very rarely have votes. We try very hard to avoid a vote. And if we do have a vote, if there are 10 people from Google and 10 from IBM and they all say yay, and one individual says no, that's pretty much a tie. Consensus means that nobody is strongly objecting. They may not like it very much, but as long as everyone can live with it and no one's strongly objecting, okay, then we're done. We very rarely have votes. And if we do have a vote, then it's one member, not one individual, one vote. So everyone has the same equal weight. So consensus is really important. So let's move on a little bit, rather than talking about process, and talk more about the way that some of the things that are going on. I was asked to try and talk about some of the future things to look forward to, and what you may be working on, if not now, then in the near future. There's an awful lot going on here. First of all, that's a Porsche, and a top-end Porsche these days has an HTML5 dashboard. And it gets its information about how fast it's going and where it is and how hot the engine is through web APIs. So there's a automotive business group that is developing a whole bunch of APIs for cars. Other people, not us, are organizing, making sure that you can get Wi-Fi in the car. Because it's really annoying that you don't get Wi-Fi in the car, so people are making sure that happens. So you've got the main screen in the front, you've got the screens on the back, you've got so that you can see how fast you're going, where you are, and everything else. If something starts to go wrong, then we're not far away from being able to say, okay, then take me to the nearest garage that has it in stock where I can get a replacement. Those kind of things are on the way. And yes, that's a linked data application. It's a web API application. It's a whole bunch of stuff coming together to make it work. As I say, the interface is all touchscreen HTML5, which is rather nice. Multi-screens. We have another interest group around multi-screen, second screen. If 3 people are sitting watching the same thing on TV, there's probably at least 4 screens in the room. The screen you're all watching and the one you're in your hand, each person. They should be able to be interlinked so that what's in your hand on your phone or your tablet, whatever, is somehow linked to what's on the screen. There's a lot of work going on with the TV manufacturers and the broadcasters to make that true. And again, the same thing would apply maybe in the back of a car. 2 people playing a game, using the car Wi-Fi to interact in that way, and also interacting with where they are. So there's all sorts of possibilities going on there with multi-screen. Sensors in the road, smart cities and so on. Antwerp, Ghent. Ghent is a really smart city, a lot of stuff going on in Ghent. So sensors in the road, actuators, all sorts of things are providing massive amounts of information. We had a workshop in Berlin 2 weeks ago on Web of Things. Web of Things being the same relationship between the web and the internet. So the Web of Things is a web of data and a web of services on top of that. So we're talking there about very, very constrained devices that just about have enough power to transmit a little bit of information with memory measured in a few kilobytes, power, very limited power, very, very constrained devices. So they then send a signal off to a server that then adds in all the metadata, and then that makes it available. So lots of work going on around that. And constrained devices makes me think back to my early days at W3, where I was working in the mobile web group. I wasn't a member starter, I was from a member organization, looking at early mobile phones, which were very constrained devices with limited memory and limited bandwidth and everything else. So the web can work with massive bandwidth, and it has to work on very small bandwidth as well. So the Web of Things, connecting up people and places and the physical world around us, is part of it as well. We also have a number of other things here. There's a physical road, there's a lay-by, there's a crash barrier, and there's some planted trees. So the road is a land use, the trees are a land use, and somewhere nearby there'll be a water stream, which is part of a water catchment area where you have to get the water to give people enough to drink and to live. The problem about the environmental data, the land use, the geospatial information and so on, is that that was developed by other people. It wasn't developed by web engineers. And cars were not developed by web engineers. And large integrated relational database systems that power industry were not developed by web engineers. But they're all pretty darn good at what they do. These 4 creatures all have stereoscopic vision. The common ancestor of these 4 is more than 500 million years old. I mean, way back, before the Cambrian. So an arachnid and an insect, yes, they have a common arthropod ancestor, but it's so far back in the evolutionary tree that they're effectively completely separate. Mollusks and an example of chordate. That's everything from a shark up to you and me. And they can all see pretty darn well. Spider's got 8 eyes, 2 main ones and 6 other ones around the back that it can see. It can see better than you can for a spider. Insects can see perfectly well. They're adapted to their own particular needs. So can everyone else there. But the point about evolution is that when you start from here and go to the next step must always be better than what you had before. It must build on what you had, and it must be better, and it gets better. It never gets worse. Because if it gets worse, it fails and dies. Same is true with any kind of technology. If you're building a large system, whatever you do next must be must build on what you've got, and it must be better. Otherwise, your boss ain't going to say yes. And the next thing must be better, and so they diverge. And so you end up with systems that are, although they might do the same job, they do it in a very different way. And there is no way that a spider is ever going to evolve insect eyes. Because to go from spider to insect, you have to go back through systems that get worse and worse and worse before you can then start getting better and better. They're all extremely good at what they do, and they're not going to go backwards just because somebody says they should. So how do we cope with that? We do have a real problem. We have a problem when I speak to the geospatial community and the linked data community, and they don't actually talk to each other very well, usually. So I ran a workshop with the Open Geospatial Consortium, which is our opposite number in the geospatial world, and Google, and the UK Mapping Agency, and the UK government. That was back in March this year. And we have, basically two sets of people in the room. There's the linked data people and there's the geospatial people, and they're trying to use each other's technology. And it's hard. Some things are easy, some things are hard, but we're trying to put them together. We have a new working group starting very soon now, which will actually be a joint OGC W3C working group, so that when you're building an application that needs to know where it is and find out information about that location, do stuff with it, you can use your web technology, they can use their geospatial, or whichever camp you sit in, and it should be a lot easier. It should mean that the data available to you in your applications is better, is richer, and is more tailored to you. Do you know about the 5 stars of linked data? Okay. So there are different worlds. There's the tabular world, there's the CSV world, CSV, JSON, and there's the linked data world. And they don't always get on. I'm normally in this group, but I quite like this group as well. And we're trying to bridge that gap between the tabular data, the tabular JSON world, and the RDF linked data Sparkle world. That's not easy either. So one of the things, one of our newish working groups at the moment is trying to, it's actually working with open knowledge data packages with Rufus Pollock, and making a W3C recommendation around how you provide metadata about CSVs and tabular data in general. We're using CSV as a shorthand for tabular data. So it might be an HTML table, it might of course be tab separated variable, who cares? It's a table, and you want to have the column headings, the row headings, other metadata, individual annotations about individual cells, data types, and so on. So that we are making good progress with, and you should be able to link from the CSV to the metadata all the other way around. So someone gives you a metadata, gives you a CSV file, and you spend the next 3 weeks trying to work out what the heck it means. You can publish that as a separate bit of metadata and point to it and say, my understanding of it is that. And of course, that table may be an API coming back, so that could be useful. And you can convert the table into linked data if you want to do that. So again, it's about bridging worlds, bridging geospatial and web, bridging tabular CSV world and linked data. That's what we are trying to do. So what should you be doing? What should you be doing now? I'm assuming, I don't know, I'll know later on as we spend some time together and I find out more about what you're doing. I'm sort of taking it that you're pretty good at HTML, CSS, and JavaScript. Those kind of basic technologies that we have. JavaScript is not one of ours, sadly, but it isn't. There we are. But we just define lots of web APIs that you can hook onto. What is ours and what is coming is web components. Anyone played with web components? Good. You're ahead of the game. Keep doing it. Widgets, iframes, different ways of inserting something, reusing components within web apps, web pages, or whatever it may be. Web components, we hope we're getting it right. When you see something like the HTML5 video element, and you use that, the browser magically knows what to do with that, and it creates a Chrome around the video with start, stop buttons and pause buttons and all that kind of stuff that goes with it, just because you put in video element. Web components allow you to define your own elements and tell the browser how to handle it. Now, as a developer, you can't actually affect the way the browser renders a video Chrome, although it does use exactly the same technology that you're familiar with. It uses CSS and JavaScript to create that, and it's part of the DOM, except it's part of the DOM that you can't access, called the shadow DOM. And the shadow DOM is how a browser actually does all the magic that you can't get to, except with web components you can. You can add to the shadow DOM. You can tell the browser how to handle one of your new defined elements. And that element can include all sorts of, it can be as sophisticated as you like. Templates, scripting, CSS, all the rest of it. You can get a really, really complicated thing if you need it to be. Define your element, and anyone can drop that element in, and all the information's there. So that's showing you how you can do stuff. It's still new. It's only in a couple of the browsers. So we're still working on it. IE and Safari are both behind on that one, but they are making progress. And you see, it won an award as being an important new technology. So if you want to think about how you can reuse components and get other people to reuse your cool components, web components is the way to go. Have a look at it, spend some time hacking around that, and see what you can find out. I really think that's going to be something that you'll enjoy playing with, and you can show off and show just how cool you can be. Web's come a long way in 25 years. We have achieved, the web has achieved, I don't know, you, the world, has achieved a great deal. Don't forget, 70% of the population have never been online. Most people on the planet have never been online and don't know why that happened. So we're working at it. It's getting better all the time. It's the most powerful interactive platform there's ever been until someone comes up with something better in about 20, 30 years' time. But we're working on it, and there's some links there at the end of there that you can have a look at and follow up on if you want. That's sort of an overall view of where W3C is. I'm happy to, I will spend the time talking with you about what you're doing. I can talk more about data than I can about HTML, but I can do various things, and if you ask me a question I don't know the answer to, I will tell you. And that's a useful kind of overview of where we are. All right. So,
the standards have been mostly developed for machine-to-human interaction, and they're running at that speed like a web page loads in up to 100 milliseconds, 2 seconds, and things like that. Also, JavaScript is rather slow, but it doesn't matter as long as it's humans. But if you're going to interconnect cars and all that kind of machines, sometimes called the Internet of Things, do you think that the current standards will be able to play at the speeds that we need there? We need millisecond and nanosecond performance.
Thankfully, I can pass that one off to the infrastructure guys. I mean, how much bandwidth is realistic? The bandwidth of mobile communications, of course, is going up all the time. JSON can be reasonably efficient, but it's useful for developers to be able to understand the stuff. We do have binary XML, so you can exchange data as binary, which is more efficient. But as long as people actually want to be able to read a URI, read the JSON and understand it so you can hack around it, we're going to get a minimum. Is it going to be fast enough?
Like that course you showed. So today, if you see what stack you have, where your final application is running, it's a hardware, it's an OS, it's a browser, it's a Java,
it's a lot,
virtual machine, and then your thing is running.
Yeah.
But in a typical car, it's embedded hardware. It's running directly on the hardware. It's firmware.
Yes.
And so for me, it's surprising to see that the display is now HTML5, and I suppose it's not running that whole stack below it. It's a more efficient implementation.
For the reason you give, I would certainly hope not. Yes. I know that if you press your foot on the brake on a Ford car, the message that goes to the brakes is sent using XML, because it has to be validated. It has to be, damn sure that information is correct. So yes, it is. There are times when XML is used. Those odd situations when you plug in a video machine to the TV, it recognizes each other by XML. It's used in all sorts of places you wouldn't necessarily think of it. that my XML colleague keeps telling me. Mission critical, yes. I don't know about nanoseconds, but certainly milliseconds. Yeah, you push your foot on the brake, you want it to work straight away, and yeah, you don't want to have some sort of JSON parse fault for that to happen. Yeah. Come on, there's one question that we get asked everywhere we go. Thank you for asking it.
What do you think will be the most exciting new standards in the
web components?
Yeah.
Web components. Use SVG. Get some cool SVG animated. Go back to the Web of Things workshop the other day. Someone was saying what we need is some nice sort of off-the-shelf gauges, so we can have a nice gauge on our dashboard for the temperature and the humidity and everything else. How can I get hold of a gauge that looks really cool? I said, make a web component, right? If you can design a really cool set of gauges that look, I don't know, various, you have steampunk ones or Starship Enterprise or whatever it may be, you can build those. Maybe using SVG would be the nice way to do it and have that available as a component. It's that mix and match that we've tried various ways. iframes kind of does it. Widgets kind of does it. But web components actually put it in the browser and make the browser work hard for you. So I think that's the most exciting thing.
What about images? What do you think will be the standard there for responsive images and like the picture?
That's now in the spec, isn't it? Picture element is in HTML5 now. How
long do you think it will take before we have like a real standard that is implemented across all browsers, and that will be like the standard everyone uses?
As part of HTML5, the browsers are pretty well engaged in that, and they do compete on speed of doing stuff. Safari tends to be behind. IE is not behind as it was. IE is a dirty name in our world, but it ain't as bad as you think. It really isn't, right? There are things about IE that are better than others.
Can I quote you on that?
Yeah, I'm standing in front of a camera. All right, I'm being careful what I say. It's worth looking at it. So, but with the What3C and our working group, they're trying. I can't answer you, but they're working as hard as they can, and it has been accepted. Apple stuck their version in early on, which was sort of an early signal that people wanted. Everyone's talking about multiple devices. The picture element now, if you haven't seen this is a way of defining. If the screen's this big, use this one. If the screen's this big, use this one. If the screen's this big, use this version, which should reduce dramatically the amount of resizing of images that goes on in the browser. Something that's been a pet thing of mine for a while. I really hate the idea of, I mean, I have to use it. I've given up fighting it, but width 100% for an image is really bad. You should have it there for lots of other for reasons I can go into if you want me to. So yeah, it's coming. And it's taken a bit of work from a few people, but it's coming. So,
is there already a package manager for web components? So you can
not that I know of, but go ahead, do it. There's a website, webcomponents.org. The specs are in various stages. I mean, it's actually 4 specs that come together in this general thing of web components. So it's an active community. It needs to grow. It is growing. I hope I'm not wrong in promoting it heavily today.
What do you think of the Polymer project?
That's all part of it, isn't it? Isn't that? Forgive me if I'm on the edge of my knowledge here.
Of Google also using web components.
Yeah.
I'm not sure if that's the only big project using it. No.
It takes its name from the various polyfills, doesn't it? I think from memory. I'm on the edge of my knowledge here, but it sounds related. And if you go to webcomponents.org, there's a big thing about Polymer. It's on there, so it's all part of it. Forgive me, I'm
On mobile devices, we see that most applications are made native, and on iOS and Android.
Yeah.
And there's a new trend of making Cordova apps with HTML and CSS and Java. And do you think that will ultimately win against native apps, and in what time?
We're trying. We have a general sort of project called Bridging the Gap, because there are things that are undoubtedly easier in a native app than are on the web. When everyone says, here, download my cool iOS app, I just say, that's actually not going to work for me. So, nice work, but don't ask me to have a look at it. You do actually limit your audience if you only do one. I know most people tend to do both, which is a pain. So, I mean, obviously, the big advantage of web is it's everywhere, from the back of your car to your TV screen, whatever it may be. The APIs for the device are getting better. So, yes, we have the vibration API. You can use the web API to make your device vibrate. It's taken time. The other thing that's also part of that actually is payments, web payments. It's easier to get money from your app, from your proprietary app, than it is from a web app. So, and it's surprising that we don't have a whole stack of standards around getting payments from the web, and we should have. And it's kind of hard to understand why we haven't. One could be cynical and say, well, because the people who do it already don't want it to be standardized, and that's true of some people. But we do now have a web payments track, so we are trying to fix that. More APIs on the devices. People like to develop once and get on everything. If you're working on one platform, I know some of you are working on Android apps, and then someone, I believe, is doing an iOS app. So you know that you are limiting your audience to that section. And then there's a guy from Microsoft in the corner who wants to shout and talk about something. So these are real things. So it will win if we can get the APIs done, if we can bridge that gap. We're working on it, we're trying. Ultimately, if you want to reach everybody, go for the web.
A little while ago, Tim Berners-Lee talked about adding some sort of DRM standard.
This is the question I was expecting, yes.
And what I would like to know is this was this his personal opinion or already the opinion of the organization? And if it was his personal opinion, do you agree or not?
Okay, so there's a camera there. DRM is an issue. We know that. We know it's a sensitive issue for a lot of people. Personally, I can only speak personally. I use, I don't know if you use this, I use web streaming DVD buying thing on my TV at home. And I can't use my preferred browser, which is Opera. I have to use Internet Explorer because that's the one that the server supports. And I find that a pain in the neck. I don't like having to use, I think I have to have Silverlight or whatever it's called to make the damn thing work. It's a pain. Copyrighted content is a fact of life. And if you decide that the web is not going to include copyrighted content, then you are removing it from that section, and you're being holier than thou and saying the web is only free, and if it's not free, it shouldn't be on the web. I can't agree with that. So what Tim said was that it was within scope of HTML5 working group to include a hook for things that could be used for DRM. And that's all he said. You can include the hook in the spec. And that's got as far as a draft. Right? It's got no further at the moment. It's just a draft. Personally, I wouldn't have a problem with it. W3C as an organization, we understand it's a sensitive issue. We don't want to annoy people. Some people in the group are more exercised about it than others. Others are not. You can't ignore the fact people need to get paid. On the other side of the fence, there's a thing called ODRL, Open Description Rights Language, ODRS. I went to a thing in Amsterdam a couple of years ago, and the newspaper industry is trying very hard to get recognition for what it does. So the journalists pay a photographer to be out there taking a picture of Beyonce as she comes out of a nightclub or whatever. That photographer is being paid by somebody. And then if you just nick that picture of Beyonce and stick it on your website and don't even give a thank you, that's kind of rude, if nothing else. Plus the fact you're nicking someone's content. So what the journalism industry wanted to do was to say, we want to be able to say, that's ours. We took that picture or whatever, and here's what you can and can't do with it. And they developed this long list of various rights and things that you can do. And I said, that's interesting. And you've built this machine-readable rights language, which is great. You've got all that information there. Machine-readable licenses, machine-readable rights statements, machine-readable this, that, and the other is fine. Who's going to build a machine to bother to read it? That's because Google couldn't give a flying fuck what you put in there. Right? They're just going to take it, and so is everybody else. So you have to somehow have something. If you need to enforce the fact that this costs, 20, $30 million to make, give it away. There's a point at which you have to be pragmatic about it. And for me, DRM is something that, yeah, it's a fact of life, and I'm not as exercised about it as some people are. Some people are very upset about it. I'm not. That's the answer I can give you, I'm afraid. I thought I might get asked that. The other one I get asked about is... Okay, any more? Or should we stop? Ruben isn't here yet, is he? There you are. Hello, good to meet you. I'll stop there then.
Yeah, no more questions?
Go Tiger!
So I would like to give the word now to Ruben Verborgh. He will talk about linked data. He's a really great speaker. I've heard him before on Frontiers. Yeah. So yeah, I'm gonna let him do his thing and enjoy.
Okay, hi everybody. So open summer of code. I hope you all have a lot of code because that's not a lot of summer right there. Do you? Okay, good. I'll check it out later because I'm quite curious to see what you've been working on. As Phil has told you, humans are no longer the only users of the web. Increasingly, we have to let machines also take part in what the web is. Those machines are cars, they can be fridges, mostly they can also be software pieces that do things on the web. Last year, 2013, something very remarkable happened in that regard. For the first time, machines outnumbered humans on the web. So in a sense, that means that basically people like me working on linked data and helping machines making sense of the web, we seem out of a job because apparently those machines are already doing a great job, aren't they? But turns out, if you read the statistics closely, actually most of those machines were simply spam bots. So that's not a really big success, is it? So in order to look at what machines actually need to access the web, or how we can make the web machine friendly and what exactly that means, let's have a look at what the web exactly is. Now, usually everybody seems to have quite an okay idea what the web is. Certainly if you've heard Phil's talk, you should have an idea, but still there's sometimes a bit of confusion what exactly the innovation was, because as a matter of fact, the internet exists from the late 70s, and then only it took until the 90s, beginning of the 90s, to actually have something that's called the web. So what exactly is the big invention of the web? What's the difference that the web made for the internet? And I'll help you a little bit. The web is a collection of basically 3 big inventions that are all connected to each other. And let's try to see if you find what those inventions are.
HTML.
You have HTML, that's a big one, of course. HTTP is the other big one, and then there's a third one that everybody forgets.
DNS.
DNS is part of it, but it's not the whole story. And DNS is also more than the web, it's also part of the internet, addressing machines and stuff. But you really have to actually URL.
TCP/IP.
TCP/IP also existed for the internet, but there's something else there. URLs. Because it's so evident. We tend to forget this, but the idea that you could identify a single piece of content by URL has been very important for the web. And here's how those 3 inventions work together. So basically, everything starts with URL, the fact that you can address a single piece of content on the web. Then, through HTTP, you can retrieve the piece of content that is identified by that URL. So, of course, underneath you have TCP/IP and DNS working and so on, but the new invention there was a protocol to transmit content that is identified by URL. If you do that, well, at least in the early days of the web, you would get back HTML. What is so special about HTML is what it contains links. It's a hyperlink language. So inside HTML, you have other URLs to find other content you can retrieve, and so on and so forth. So this is the basis of the web. It's an information system, and there's a whole cycle of getting things, and so on and so forth. So those URLs, what exactly do they identify? Well, the principle of the web is that they identify resources. Now, this is a very broad thing, of course, and maybe doesn't really help. But note that there's not something like that, like actions or operations or anything. It's resources. Conceptually speaking, the URL identifies a thing that you can retrieve, manipulate, and so on and so forth. And this notion really helps with how we can deal with web at large scale, which I'll get back to later. So those are the basics of how it works for humans. So HTML, following links, as we all do on a daily basis, I'm quite sure. Now, what does it say for machines? So will machines also do the same things? Will they also be reading HTML? Well, some of those machines will be reading HTML. Think about Google, for instance. Think about spam bots. They all do it. But HTML is maybe not the right format for machines because it has been designed for humans. So can we do something more? Essentially, when designing for machines, there's two broad strategies you can follow. Plan A would be just do whatever it is that we've been doing before. So we've been developing applications for, what is it, 20, 30, 40, 50 years, even not as specifically, but in general. So we can just reuse the same principles. And one of the dominant principles that we learn if we follow an IT course is method calls. So we could just say, well, we'll disregard whatever idea there was with URLs and content and stuff. We'll just do method calls. So we'll wrap whatever we have as a method. So if you want information about a person, well, we try to make it a method. We give an ID, we give an action, and we give the format and something. And notice it's a different format here because machines can interpret HTML. So I'm not criticizing this particular structure of a URI or whatever, that would be pointless, but it is about the philosophy here, the idea that suddenly you use the web to execute actions. So this is one way to approach it. Now the problem with this kind of thinking, the way of thinking there is that you have two different webs. There's a web for humans, where URIs address content, where people follow links, and where you have this whole network of information that you can go from any point to any other by following links. Then the other system, the second web, is then for machines where you just have an RPC interface where you just call methods and that's it. But there's not really an advantage in doing something like that because, first of all, you have to build two systems. Now, this is good news for us developers because this means we're paid twice. But it's not how I want to make money, actually, if I do the same thing twice, just slightly differently. The other bigger issue is with all kinds of different devices, different people, different laptops, mobile devices, tablets, whatever, accessing the web. In how much pieces are we going to divide it, actually? I think it's more interesting to have a system in which machines and humans and any other kind of device, cars, doesn't matter, have the same kind of interface, so that we can exchange identifiers, that we're talking about the same things. But we only have to build one system, but just at the end that we have to deliver different formats so the machines can understand it and the humans can understand it as well. So the plan B is let's embrace the web the way it is. Let's learn from its principles. Let's learn from why the web has scaled the way it has, why it is so easy to use, and so on. This means when I design APIs, I also think about resources. And my API for humans would look like this. Well, you want a person, just get it, whatever. Again, it's not about a specific URL, but just conceptually, this is a piece of information. Well, let's a machine use the same URL to also get a piece of information. This has been referred to as the REST principles and so on, but I don't like to use the word because everything is REST nowadays and so on and so forth. I like to think of it as hypermedia principles. It's using the web as a big hypermedia system, using identifiers to identify content and not doing actions over the web. You could say, okay, well, we have this one URL that we could share across systems, but how are we going to ensure that humans can read it and that machines can read it? Any suggestions on that one?
Checking if the machine or the client is asking HTML or JSON.
That's right. And how's the process called?
Checking the headers.
C, and it's two words. Content negotiation. But the principle is right. So basically the idea is that the identifier stays the same. But as a human, your browser will say, well, my human actually wants to see HTML, and then the server can say, okay, it's human, I get HTML. And if you do the same thing, well, then the machine would say, actually, I don't understand HTML, give me JSON, or give me something I understand, and the server can do that. Now, note this is not about aesthetics for it. It's not about having beautiful URLs and following the specs and principles. It's really about using the same identifiers regardless of who is a consumer. It's about thinking in terms of information, not in terms about programming and all the other things we like to do. So indeed, machines, they would not receive HTML, that's for humans, and machines would retrieve JSON then, so they can interpret it as well, for instance. Now the bigger message here is that I encourage people not to build APIs. Because building APIs is a really hot topic nowadays. Everything needs and has an API. Actually, it's not necessary, because if you think about it, your website is an API. It's an API for humans. It's an API for content. You offer the content in certain structure. But instead of having a totally separate system for machines, with the same effort, you can also make a machine accessible. Just give them different formats. And this is not about how things look from the outside, but really the philosophy of how we can deal with heterogeneity of clients on the web. So this brings me to the next part. So this would be the principle, the philosophy of building APIs, but how can we use such APIs to make smart clients, and how smart can we make those clients? Because the issue I have a bit with semantic web stuff, so the big vision of the semantic web, is that people focus on this question. How smart can we make clients? Let's try very advanced things so that people are really, blown off their socks because of the power of our clients. I think at the moment this is the wrong question, and it's one of the reasons we don't see too much semantic web stuff in the real world. I think the better question is, how can we make our clients smart? How can we just do little things to ensure that we have clients that are not tightly bound to a specific API that can do interesting things on the web? So the first question that I ask myself if I want to build such a system is, how would I do it as a human? How would a human approach a certain task? And again, this fits well with what I explained earlier, the fact that we have this single vision on the web for humans and the web for machines. So let's just, if we want to solve something on client side, let's have a look at how humans would do it, and then try to generalize this towards machines. So I'll give you a question, and the idea is, how would you solve it as a human? You want to find out artist born in Antwerp. How would you go about this task?
Search it in Google.
Search it in Google. So you search for the whole phrase, or what would you search exactly?
The core words.
Core words. So it would be
artists Antwerp.
Artists Antwerp. And you expect to see a full list there.
Wikipedia or something.
Okay, so your hope is that you will eventually arrive on a page that will have the list for you.
Yes.
Good, makes sense. Except if the question gets a little more complicated. Which artists were born in Antwerp but live now in Brussels? How would you do that?
I would add more sentences.
And you would expect there to be one single page that has exactly the answer that you're looking for?
You have to parse it yourself.
Okay, how would you parse it? By the way, you can help him out. I'm not attacking this guy personally.
Yeah.
Good, two people help.
I would first search which artists are born in Antwerp, and then I would look at which artists are living in Brussels now, and then cross-reference, see which ones match both to this.
Makes sense. What's your plan?
I would read all biographies of the artists in Antwerp, which I found on Wikipedia, and then look at if there's one in Brussels.
If I were to employ any of you two, I would pick him, because you spend a long time doing it. But I mean, it's a free world, so you can do whatever you want. Makes sense. Unfortunately, do you have another suggestion?
Another plan is to search Wikipedia and query this stuff.
Ah, interesting. I didn't expect this answer, because this would be the traditional semantic web answer there.
Yeah.
So I give a little bit of background, but I won't bore you too much with the technical details. The current idea of Wikipedia, which is the semantic web linked data version of Wikipedia, is to turn all these facts into triples, little pieces of information, and then they have something like a public endpoint where you can ask a complex question. So just say, I want to see this. This doesn't really work in a scalable way, because you can imagine lots of clients asking very complex questions. This is quite hard, because the web is built on not on question answering, but on service deciding what information they offer. If I'm the city of Antwerp, let's say, I can offer you a list of buildings, for instance, but I can decide that I will not let you search those buildings by name or by number of stories or whatever. I decide how the information is offered. The semantic web has tried to reverse that, saying, well, You can ask me anything. Basically, this is the equivalent of giving your user a bazooka. So here's a bazooka, here's a rifle gun, shoot me, I'm ready. This doesn't scale. What I'm even doing is looking at how we can do smaller things. Let's say we give other users chopsticks, and you can just tap me a little on the arm. And even if thousands of users do it, okay, it will hurt a little, but still, I can survive that. We'll actually come right to that. So I have kind of translated this question in semantic web speak. Don't be afraid, it's actually quite simple. So we just say, I'm looking for a person and city, where person is an artist, person is born in a city, and that city is named Antwerp. How do we solve it? Well, you are going into the right direction in the sense that we won't expect one single oracle somewhere to answer this question as a whole. Let's try to break it down in smaller questions. Let's look at cities named Antwerp. Maybe they're different all the time. Let's look at people born in certain cities. Let's look at people that are artists and then combine them together. By asking smaller questions, we ensure that we won't bother the server too much, and also assure that those questions are cacheable and reusable, because maybe different people are interested in artists, but maybe not artists in Antwerp, but maybe artists in Brussels, and so on and so forth. The solution that we've developed is a combination of a smart API and a smart client, and I will show you how it works in a second. So we call it linked data fragments. What we do is we pick small fragments, not so precise fragments of a linked data set. The client can ask for those fragments, and then it will combine them itself to interesting answers. Let me show you how that works. Good. So this is a client, but I'll first show you how the data is partitioned. For instance, let's say we're looking for information about the city of Antwerp. So what we can do is we can ask any pattern of tree triples. It's not more complex than that. Note how I, as a human, can do that. I could actually copy-paste that URI and let a machine do it. It would get JSON LD with the same kind of information. This is how such an interface works. We can ask simple questions. Give me anything about Antwerp. Give me anything about, let's say, Brussels, for instance. That works like that. It's all kind of simple questions, and those simple questions ensure I have an API that is stable, that doesn't go down, and so on and so forth. What we have is a client application that uses this simple API to solve complex questions. And notice this is a very interesting client, because essentially it's a client you can ask any question at all. It will try to answer it using basic pieces. So here we have the same query. Give me artists born in a certain place. That place is named Antwerp. Let's query that. And we see the results coming in right there. You can say, wow, this is really fast. Did you really do this? Well, yes and no. I just tried it earlier, and some of the results have been cached. So as a result, it's quite fast. So let's try this with another kind of city, and this is a risk because I'm date right now, and this is live. So name me any other city that could be there.
Barcelona.
Barcelona. Okay, let's see it. Good. Stress. There you are. So I don't know whether they're correct because I don't really know one of those artists, but you can trust me that they are. Here at the bottom, you see all kinds of small questions being asked to answer a complex question. So this is a new kind of generation of clients that does things that you know, it has been coded to solve complex questions, but the flexibility of questions you can ask is quite broad. And this is not really unique, but it's already going into a different direction of building clients. So not really just one simple question, one simple answer, but more complex answers, intelligently using existing APIs. Yes, so I'll stop it right here. You can play with it if you like, by the way. It's on client.linkeddatafragments.org. So, to summarize, the message that I have, if you want to build those systems that are fit for clients, if you want to enable clients to do things with your API, if you want to enable humans to do things with API, the last thing that you have to do is design smart servers. So don't start with the complexity right there. Whoops. I don't know why I don't. There's this. So don't design smart servers. Don't try to put all the complexity inside the server. Don't think too much about what kind of complicated actions your API should do. Instead, your job as a designer of APIs, as a designer of web applications in general, is to ensure that your design enables smart clients. This is something completely different. It's a totally different way of thinking. Don't try to be smart yourself because you have no idea what kind of different clients that you would have. They could be cars, they could be fridges, they could be I don't know what. So if you are trying to be too smart, then you don't enable those clients to be smart, because the only smart things they can do is the smart things that you offer. If you think about it, design in such a way that you enable others to be smart, then we can get really, really cool clients. And if you think about it, this is how we humans approach the web. Web pages just give you information, and it's up to us to do interesting things with that stuff. So that's the whole principle. Designed to enable others to be smart. Don't be too smart yourself. I think this is a cool way to deal with the fact that we are no longer alone in the web as humans.
In light of the complex queries, you launched a conquest to bazooka everyone's Sparkle endpoint. Did anyone take you on that challenge, and did you succeed? Or did they succeed to keep it up and running? Or?
Very good question, and so yes, we tried it actually. So the thing is, it's always a trade-off. Sparkle endpoints are really, really fast. If you give them a query, they can answer it almost instantaneously, but only 95% of the time. Like major sites like DBpedia, they're down for more than 1.5 days each month. So what we've tried, we've put up an experiment, and by the way, I am a researcher, so I do all kind of nasty science stuff next to programming. So we did an experiment where we indeed had an Amazon cloud with a lot of virtual servers and like hundreds of clients, and we just bazookaed the hell out of the Sparkle service and also of our own servers. What we saw is that, yes, Sparkle servers, if they were up, if they could withstand all the force, they were faster. But as the number of clients increased and increased, they were getting slower to the point where they dropped off, and eventually we were faster because Sparkle endpoint didn't answer anymore. So this approach works, but it is designed for lots of clients. But again, there's a chicken and egg problem. There's not a lot of clients now because there's not a lot of availability and so on and so forth. So we say, this is simple, it's cheap, it doesn't cost a lot to host this, it's reliable, it's not so fast yet. We'll see about that.
Is it better to place the Sparkle endpoint to the clients more or to the server?
Well, that's a very interesting question. So what we've been doing here, so let me first say in general. In general, if you have data, what you always do is try to move the processing as close as possible to the data. This is the most efficient, of course, do processing early in the habit. On the web, it's a wholly different model, because right here, the server, let's say it's open data, just offers data for free. Here you can have it. And it is a client who has the incentive to know the answer to a complex question. So is it really fair that the client say, well, I'm really curious, here, solve it. I think that the philosophy where you as a client, you ask a question, you just wait until somebody else has to work for you and then gets back to you. I don't think it's realistic on the current web yet, because that's not how it works. So to answer your question, what we have in fact here is we have a Sparkle processor that's happening on the client side. And the server, you could see the server as a really live Sparkle endpoint that allows only one triple pattern queries. And that way it doesn't go down. So the future plan is that we try to see if we give the server a little more power. For instance, let's say 2 triple patterns or maybe some filters. Can the server still be reliable, and can the client then do the remainder of the work? So it's not as much as put it on the server, put it on the client. It's let's see what exactly the best position is to put it in the middle. Let's see what's best for performance and for the ecosystem, basically.
Is there already being worked on serving the API local caches? Like if you request the things from DBpedia and that now it's in Antwerp and anyone asking it now will get the answer from Antwerp?
Yes, and that's a good thing about this kind of system. So you can simply do the cloud caching basically, and that's what we also do. So we have our own server and we just put the cache in front of it. Now you can always do that, but here it's effective because if you have a Sparkle endpoint, if you have a SQL server or anything, each client asks unique questions, so you can cache as much as you like, but the chance that somebody will ask the same thing twice is very low, so it won't be effective. Here, because, like I told you, there could be overlap. Somebody else could be interested in an artist while having a completely different complex question. So we can do caching. We put the cloud cache in front of it. Can be a server in Antwerp, can be in Chicago, or whatever. And they'll be able to have local caching of the fragments, and it will be effective because the granularity is a lot different than its Sparkle endpoints.
Is there
Yep.
Is there a linked data editor in which you can edit the data and make it up, or is it still everything by hand, like adding stuff and?
So what you would like to do is edit triples manually, or what is the?
Yes.
So again, I would not employ you because we're talking about millions of triples here. No, but it's a good question in the sense that yes, you can do editing stuff on triples, but I wouldn't redo it on the triple level. So I would be looking at large-scale data manipulation tools like OpenRefine, Google Refine, for instance. So you can load triples into them, process them in batch, and then have them cleaned up, linked to other triples.
Because I would like to transform my own website where I list my projects into linked data project where I have a list of my projects, and I want to be able to add some of them and edit, and then hook it up to a templating engine. And
so in essence, what you would want is a linked data database of your stuff, and then have a front-end generator on that to serve your content. Is that? That's a good one, actually. I kind of do this for my own site for parts, but I'm pretty old school. I do this in text editor, so I choose triples manually. That might not be the best approach for large amount of data, but I use it the same way with a templating engine to translate it into HTML. So there are options, but I think filmmaking has better ideas there.
Not better ideas, no. A couple of things come to mind. RDFA, so you put triples in the HTML, embed them in that Swan web. So you're still creating a web page, but you're embedding triples within it. But I can imagine you might pretty easily hack up your own little input form, where you would put the name of your project and a few other bits and pieces, and you click go, and it would populate your database. If you're adding your own projects, that kind of small scale thing. And also picking up on some of what Ruben's been saying about simple queries or limited queries being easy to execute. All those ideas come together in a new working group we have called RDF Data Shapes, which should be starting soon. We need you in it.
Good. And that is JSON or XML or both? Or?
It's RDF. It's an RDF data shape. So what you do is you specify the shape of the graph. So if you have one of these classes, it should have these properties, and the properties should have one of these values. The kind of thing you're used to with XML schema, kind of closing the world, which is a horrible thing to do in the linked data world because we like open world. We like the idea that anyone can add more data. But sometimes in a practical situation, you want to have a closed world. We're trying to find a way of doing that. The point I'm trying to get to is that that file would be useful for a number of things. That file that describes the shape of the graph can be used to auto-generate a web interface where you have mandatory fields and optional fields where you must provide the data and the machine spits out the HTML with RDFA. It also tells the Sparkle query engine, you don't have to look for these other possibilities. Every bit of data in here will conform to this shape. Therefore, don't spend processing time looking for outliers that we know are not there, which actually means your Sparkle performance can improve, so fewer of your Sparkle endpoints go down. But I really like the approach that Ruben's been working on, this idea of taking, a larger set of what you want from the web, and then bringing it internally and then doing more complex processing locally. That's a really smart idea, I think, and I like that way of doing it. But I think to answer your point, RDFA is the basic way to get the data on your HTML page, and RDF Data Shapes might be a way to help you build a tool that makes it easy for you to do it. If you want to shift around millions of triples at once, there's another thing called Linked Data Platform, which is designed to do that. Shift an arbitrarily large amount of triples from A to B using a thing called HTTP.
So you prevent millions of requests and just do one.
Yeah.
The query language Sparkle, yes. What kind of database lies underneath it? Is it just MySQL or more optimized?
So there are specific kind of Sparkle endpoints or linked data databases, RDF databases, and they're implemented in different kind of ways. So you have very specific implementations, for instance, a hexa source system where you have 6 kind of indexes to do the stuff. It is possible, of course, to implement it on top of a regular database, and this is kind of the approach that Virtuoso, for instance, takes. So Virtuoso is a big general-purpose database, which also has a very good Sparkle interface there. So you have different kind of combinations. In the end, it's all just triples. If you want to store them, let's say, in a simple table, you could do that. But if you're talking about lots of triples, I go for dedicated triples in that case. Good. So I suppose everybody else is hungry, so maybe we should proceed to lunch next then.
All right.
Ja,